All right, welcome back to Chapter 6, Polynomials. This is Lesson 6.4. So far, we've done 6.1, 6.2, and 6.3. That makes sense. So let's take a look at what we're going to learn from 6.4. If you look at this check sheet, you can check off factor a sum of cubes, factor a difference of cubes, and then factor using a quadratic pattern and solve using a quadratic pattern. So make sure that by the end of this video, you understand how to do those things. So our lesson objectives, one of the objectives that we could have done was solve by graphing, but we're not really going to do that. We're going to solve by factoring. Alright, so a couple of our key concepts. If you remember back when we talked about a difference of squares, it might have been x squared minus 9, which we could factor into x plus 3 and x minus 3. We can do the same sort of thing with the sum and difference of cubes. So, if we have a sum of cubes, so that's a cubed plus b cubed, a sum of cubes, that makes sense, we can split that or factor it into two pieces. The first piece is always going to be this same thing, only removing the cube. So if there was a plus here, we're going to have a plus here. The second part of it, we always need just one minus sign. We don't have a minus sign yet, and the last one is always a plus. So if this is plus, this is minus. If this is minus, this is plus. So that's a good pattern to think of. So we have a plus b, and then our second part is just a squared minus a times b plus b squared. That's for the sum. For the difference, we do the same thing. We've got the difference, a cubed minus b cubed. So for the first factor, we just remove the cubes, and then we split it up. We used a minus already, so both of these are plus. And it's a squared plus a times b plus b squared. All right, let's look at example number 1. We're going to solve this polynomial equation. Remember, solving means there's an equals here, and I want to know what x is. And in this case, we're going to find all the complex roots. So if you remember, complex roots means that we're going to involve a square root and probably some sort of imaginary number. So if you look at this, this looks like a sum of cubes because 8 is really 2 times 2 times 2, or 2 cubed. And x cubed is x cubed. So we can split this up into 2x cubed plus, well, 125 is really 5 times 5 times 5, or 5 cubed. So look at this. This is a sum of cubes. So let's go back to what one of our key concepts was. We have that handy-dandy little equation. So we can factor this into 2x, or a, plus 5, which was b. And remember, we didn't use a minus sign yet. So we want this thing squared. Well, 2 squared is 4, and x squared is x squared. This is a plus, so this has to be a minus. Now a times b, or 2x times 5, which is 10x, and then finally plus b squared, or 5 times 5, which is 25. This equals 0. Remember that in order to multiply two things together and get 0, at least one of them has to be equal to 0. So that means either 2x plus 5 is 0, or 4x squared minus 10x plus 25 is 0. I wonder if we might be able to factor this thing. Let's think. If we use our tic-tac-toe factoring, 4, -10, and 100. Are there two numbers that we can multiply to get 100, or to get 100 and to add to get -10? Well, they'd both have to be negative. Let's think, 1 and 100. If we add those together, we get -101. That doesn't work. -2 and -50, that'd get us -52. That doesn't work. 3 won't go in there. How about 4? -4 and -25, well, that's -29. We're getting closer, but we're still not to -10. What about 5? -5 and -20, -25. Will 6 go in? No. 7? No. 8 won't go in. 9 won't go in. What about 10? Well, -10 times -10 is 100. Well, that's -20. So we can't find two factors that will get us to -10. So what we're going to have to use instead is the quadratic formula. So let's take a look at that. So our two factors were 2x plus 5 and 4x squared minus 10x plus 25. Those equal 0. So our first thing says that 2x plus 5 is 0. And the other one says that this thing is equal to 0. All right, well, this one's simple enough. We can just get rid of the 5 from one side, so subtract 2x is -5, and then divide by 2. X is -5 divided by 2. So that's one of our solutions. Let's take a look at this. This is still a quadratic, and we figured out before that we can't factor it, so let's use the quadratic formula. Remember, A is 4, B is -10, and C is 25. And if we remember, the quadratic formula is x equals -b plus or minus the square root of b squared minus 4ac all over 2a. That was a kind of a bad version, but you know what I'm talking about. All right, so let's plug these in. So in this case, x equals the opposite of b. The opposite of -10 is +10 plus or minus the square root of b squared. Well, -10 times -10 is 100 minus 4 times a, which is 4, times c, all over 2 times a. All right, let's simplify this monster. Well, 4 times 4 times 25 is 100, right? 4 times 100 is 400. So 100 minus 400 is going to give us -300. Remember, we talked about that we're going to have some complex roots. Let's put the rest of this here. All right, how are we going to factor -300? We know we can take out a -1, and then let's think about how to factor 300. Things that might be factorable, well, what about 25? 25 we can take out of there. How many quarters are in $3? Well, 12 of them are. All right, what about 12? We could split that up. I know 4 I can take the square root of, right? So 4 times 3. So this thing really becomes the square root of -1 times the square root of 25 times the square root of 4 times the square root of 3. It's a whole lot of square roots, right? All right, so if we do that, we get x equals 10 plus or minus. How do we represent -1, or the square root of -1? We call it I. What's the square root of 25? It's 5. What's the square root of 4? It's 2. So 5 times 2 gives us 10. And then we're left with this lonely little square root of 3. He needs to stay where he is. And this is all over 8. If you get to this point, I will be fantastically thrilled. But if you get to the next step, I'll be even happier if that's possible. Look at this. We've got a 10, a 10, and an 8. So I can divide all of those by 2. So if I do that, that becomes a 5, that becomes a 5, and that becomes a 4. So my final answer is going to be x equals 5 plus or minus 5i square root of 3 all over 4. So your notes tell you that you need to fill in one last box, and it says the solutions are, in your first box, you'd put negative 5 over 2, and the second one was 5 plus or minus 5i square root of 3 over 4. I may have forgotten the I in the last thing. I apologize. All right, let's look at example number 2. We're going to factor a sum or a difference of cubes. All right, so factoring these, look at this. Let's split this up into our A and our B. Well, x cubed is really x cubed. And 125 cubed, or the cube root of that, this is really 5 cubed. So we can factor this. This becomes x minus 5. Remember, we just removed the cubes for the first part. And then x squared. We already used up a minus, so this is plus. And then x times 5, which is 5x. And finally, 5 squared, which is 25. All right. This is going to be a bit of a challenge, but I know that you're ready for it. All right, this doesn't look like a quadratic, but it says that it's a quadratic, doesn't it? X to the 4th minus x squared minus 27. Let's look for a pattern. X to the 4th is really x squared squared, right? And then minus 6x squared minus 27. So what if we replace this x squared just temporarily with something else? We're going to use a, and we're going to plug in everywhere where there's an x squared, we're going to put a. So this becomes a squared, because a was x squared and this is squared, minus 6a minus 27. Now that looks like the quadratic that we've come to know and love. I wonder if we might be able to use tic-tac-toe to factor this. Let's try. So we have a 1, negative 6, and negative 27. So what are two numbers that multiply to be negative 27 and add to be negative 6? I think it's negative 9 and 3. So our greatest common factor in both of these cases is 1. 1 times what is negative 9? Well, that's negative 9. 1 times what is 3? That's 3. And in this case, our variable was a. So I can split this up into a minus 9 and a plus 3. But we don't really want a. Remember, we started with x. Well, what's a equal to? It's equal to x squared. So let's go ahead and plug back in. Anywhere where there's an a, we're going to put an x squared. So this becomes x squared minus 9 and x squared plus 3. All I did was replace each of these a's with the x squared. Well, look at this. That looks kind of familiar. Looks like a difference of squares. We could split this up into x minus 3 and x plus 3. If you're a little suspicious, pause the video and use the tic-tac-toe to figure out what your two factors would be. This isn't a difference of squares, so we're just going to leave it as x cubed plus 3. So we used a quadratic pattern, this is the pattern, to completely factor that polynomial. Oops, that's a squared. All right, let's take what we just learned. If you haven't done the quick checks, please go back and do so. Pause the video and do that. So let's solve a polynomial using that same pattern. All right, so let's take what we just learned by factoring using a quadratic pattern and actually solve it this time. That means that, remember, this is equal to 0. We actually want to know what x is. So let's take a look at our pattern. Remember, x to the 4th is really x squared squared. Minus 4x squared minus 45 equals 0. So let's replace, just temporarily, we're just going to substitute, like in basketball, one player in for another. Everywhere where there's an x squared, I'm going to put a. So this becomes a squared. There's the a, there's the squared. Minus 4a minus 45 equals 0. Now this looks like a quadratic. I wonder if we can use tic-tac-toe. Let's try it out. So 1, negative 4, negative 45. So two numbers that multiply to be negative 45 and add to be negative 4. I know the bigger one's going to be negative. So how about negative 9 and positive 5? So the greatest common factor, because there's a 1 here, these are 1. 1 times what is negative 9? Well, that's negative 9. 1 times what is 5? Well, that's 5. Those are a's. So I can split this up into a plus 5 and a minus 9. That's great, but I don't want to know what a is. I want to know what x is. So now we need to put our original player back in. Everywhere there's an a, we're going to put x squared. So this becomes x squared plus 5 and x squared minus 9. Well, look at that. That's our lovely little difference of squares. So we can further split this up into x minus 3 and x plus 3. But let's not forget about this. X squared plus 5 equals 0. Remember, our goal is to solve. So in order to multiply this times this times this and have it equal 0, at least one of them has to be equal to 0. So we're going to set each one of these equal to 0 and solve for x. So let's copy these down. We've got x squared plus 5, x minus 3, and x plus 3 equal to 0. So let's take these systematically. So x squared plus 5 equals 0. X minus 3 equals 0. And finally, x plus 3 equals 0. Let's take a look at this one. If we want to solve for x, we need to move that 5 to the other side. We're adding it, so the way we undo adding is to subtract. So x squared equals negative 5. How are we going to undo squaring? Well, take the square root. So this would be x equals, remember when we take the square root, we need to think about its positive or negative, square root of negative 5. But we don't like to see that negative in there, so how do we deal with that? This is an imaginary number, so we bring that I out. That square root of negative 1 becomes I. So square root of 5, and then plus or minus. Now let's deal with these. How do we undo subtracting by 3? We add 3 to both sides. So in this case, we get x equals 3. And finally, how do we undo adding 3? We subtract it. So x equals negative 3. So our solutions are positive I square root of 5, negative I square root of 5, positive 3, and negative 3. Make sure you do the quick checks. Have a great day.